All right. So, almost done with chapter 9. We got one more after this one, but before we get into 9.6 here, we got the kickoff from last time. Packaging list a model's car's length as 7.6 centimeters. So it also gives a scale as 1 to 63. So what is the length of the actual car? So again, can't have a full-size toy. So we always make it smaller. We base it off of a scale so that it looks like the real thing, but it's just smaller so we can have it as a toy. So what we're going to do is we're going to set up a proportion. So it's 1 to 63 is the scale. So the toy to the actual. Okay. So set up the proportion. The toy's length would go on top. So if they told us the model car is 7.6 centimeters, that's going to go on the top. We're looking for the bottom. So cross multiply and solve. We'd multiply these two, divide by 1. So x is just going to equal 478.8 centimeters, which is going to be 4.788 meters, depending on what units you want to use. Okay. So get into 9.6. So this one's going to be all about compositions of reflections. So everything that we've done with transformations, any two figures that are congruent would be an isometry. Now, if there isn't a reflection, we call it either rotation or translation. However, any two figures, and we're going to get into this, really, as long as they're congruent, could be made up of a series of reflections. So first off, if we're looking at this, so we have two figures here. They're fives. So is this going to be a translation, a rotation, or is it something else? Well, technically, if we had something right here, we would take this and we would rotate this around. So this would be a rotation. Okay, we talked about that back in, I believe it was 9.4 was rotations. 9.3, I was close. 9.3 was rotations. So we could take it, we could rotate it about a point, and we would have it match back up. Or wouldn't necessarily match back up, but we'd rotate it, okay? Here we have two figures. We're looking for, are they going to be a translation? So could we take this and slide it over? I'm off the page, sorry. If we take this one, slide it over, well, no, it wouldn't match up, so it wouldn't be a translation. Well, if we rotated this, again, we're not going to be facing the right way, so it can't be a rotation. So this one would be an other. Now, what is that other? Well, it would be a reflection. But not just a straight up reflection, because that would be a straight over. It'd be a series of reflections. So probably what happened is they took this, they reflected it down. Well, it could have reflected it down again. So that'd be the same way again, and then reflected it over. Or we have a slant here where we're reflecting it that way. Oh, no, it can be a slant. But anyways, it'd be a series of reflections is what I'm getting at. And that's going to be explained here in some theorems. So first we have theorem 9.1, which is a translation or rotation is a composite of two reflections. So we could flip it, and we'd have that translation over. We could flip it, and we'd have that reflection or rotation. Now I'm going to show you what I mean by that in a little bit here. We could also have a composition of reflections across two parallel lines to make it a translation. So there's more specifically there. So like this is what I'm talking about. Two parallel lines. If we reflect, it would make a translation. Now I'll show you that in a moment. So 9.1 just states it in general, and then these two are getting more specific here, where 9.3 states a composition of reflections across two intersecting lines would be a rotation. So that's what we're going to do on the next one. And again, I'll show you what I'm talking about with that. So if we find the image R for a reflection across line L, followed by a reflection across line M, then describe the resulting translation. So if we reflected about it, so we're a little bit angled, so it's not just going to be a straight across flip. It's going to be a little bit here to the side. So this here, when we flip it, would look something like this. Now, my R is not exactly the right, but it'd be where we're flipping it across, so it's going to turn it a little bit, plus it's moving it over. Well, that same thing is going to happen here now. So now it's going to flip it this way again, and so it's going to right it back up with our R. Oh, I should make that a curved R like how that one is. But again, so we flip, and then flip. So what it makes it look like is we've taken this and we've just slid it over, but it's really two flips that are going on here. So because we're a little angled, we reflect it over, again angled again, so reflect it back to level it out, but it looks like we just slid it over. So that's what 9.2 is really talking about. We're taking two different parallel lines here and reflecting it, doing two different reflections to make it look like we slid it. So if we do rotational, so again, we're a little bit off. So we're going to turn just a little to make our R. And then we're going to do some more because we're reflecting across this one, reflecting it back. But again, it's making it look like we're taking this and we're rotating it around whatever these angles are. So we have an angle of intersection here, and that'll cause reflection across the two lines to make it look like we rotated. So that's really showing what 9.3 was all about. Now, if 1 in this case is 35, well, think of if we had our line here, that 35 would match up here. So 35 and 35, and then a second 35. This would really be, no, what am I talking about? This would be a 35-degree rotation. So cross these lines. If 1 is 35, that's like taking it off of here and rotating it that far. Okay. Crap, I was on, shoot, I shouldn't have said crap, my bad, and then I said it again. So yeah, like I was saying, if we move this so that the lines were in the center, that 35 degrees would be center to here. So a second center, this really isn't 35, this is a 70-degree rotation. It's not quite 90 from here to here, but it's like if we were here with those lines, 35 would get us to the middle of this one, another 35 would get us to the middle of that one. So whatever this angle is here in the middle, that's how far it is that you're rotating each one across each line. So each line would cause that much of a rotation. Okay. So 9.4, which is the fundamental theorem of isometries. So in a plane, two consecutive figures can be mapped onto another by a composition of at most 3 reflections. So that's where I talked about before on this this high, we would flip, and then flip over. So 2 vertical flips to get it back the same way, and then a flip over to switch the deal to make it look like we slid it over. Okay. So if we find the image here, we can also do a glide reflection, which we have 2 different, not just reflections, but we'd have a reflection, and then in this case, the glide part is this slide, the translation. So we would slide it and then flip it. So we're always going to go parallel then to the direction of the translation. So if we slide down, we would reflect it over here. So it'd be like another line that's parallel to the way we slid, reflecting across that. So in a way, we're going to slide it, and then the flip will move it perpendicularly, but we're flipping across a line that would be parallel. So we do the translation first. So in this case, we're going to go, so the x isn't going to change. X is going to stay the same, but we're doing the y as a -5. So this is going to move it straight down. So everything's just going to move straight down 5. So if we're here, we're going to go 1, 2, 3, 4, 5 to get our x prime. E, 1, 2, 3, 4, 5, which is E prime. And then 1, 2, 3, 4, 5 gives us our T prime. So connect, connect, connect. Okay. So from there, we're going to then reflect it across the y-axis. So our y-axis right here. So again, however far off we are, we're going to be that far the other way. So if E is 1 to the left, we're going to go E double prime will be 1 to the right. T here is 1, 2, 3, 4, 5 across. So 1, 2, 3, 4, 5 will give us our T double prime. And X is 2 over to the left. So we're going to do 2 to the right and X double prime. And there we have our triangle. So we take the triangle, the glide part, we slide it, and then we flip it over for the reflection. So glide, reflection. Okay. So ways that we can do different isometries here. There's 4 different ones. So reflection, we take it, we flip it over a line. Translation, we take it and we slide it. And then rotation, we take it and then we rotate it. So these were the 3 that we have done earlier in chapter 9. And then glide reflections, what we just did. So we'd slide it and then flip it over. So black is the one that starts it. Blue is the one where we end it. So we flip for the reflection. We slide it for the translation. We turn it for the rotation. And then the glide reflection, we're going to do both of them where we slide and flip. Okay. So each figure is an isometry image of the figure at the left. Tell whether their orientations are the same or opposite, and then classify the isometry. So we have these 4 isometries. We have 4 options, and yes, we're going to use them all. So here we have spin, just how you normally see it with the arrow on the bottom. If you think about it, this acts as our line of reflection, and we're flipping it over, so now we're the opposite way, and we're pointing that opposite way. So this would be an opposite as far as the orientation goes, and this would be a reflection. So all we're doing is we're just taking it and we're flipping it over, and we have our mirror image. So here, so it looks like what this one was, but we've also rotated. So this one's also an opposite, but it's flipped and that rotation. So it's not just a straight slide. So we haven't just taken it and moved it over. We haven't just done a flip, and we haven't just rotated it. So if we haven't done a reflection, a translation, or a rotation, it's got to be the glide reflection. This one would have been one where we moved it and then flipped it over, and it would have been an angled line of rotation. So this is our glide reflection. Okay. So see, it looks like the exact same thing. So all we've done is we've just taken it, we've slid it over. It's the very same orientation, so there's no flip going on. All it is just a slide over. So that would be a translation. Well, what's the only one that's left? Well, if you think about it, if we turn this around, now it looks like spin. So all we've done is just rotated it around. So this one, again, it's the same orientation, but it's a rotation. We've taken it and we've just turned it. So if you think about it, anything with a reflection, it's going to have that opposite orientation. It's going to flip over, so it's going to look like a mirror image. So if you look in the mirror, everything's the opposite way. So if it's just straight up, it's a reflection. If it looks like it's moved a little bit, plus that opposite direction, it's going to be a glide reflection. If it looks the same, like all we've done is just moved it over, that means same. I mean, there hasn't been any turning, anything. It's the same orientation. You know, it's spelled the same, looks the same that way. Nothing's been flipped. That's also nothing's been turned. It's just a translation. We've just slid it over. And lastly, it looks like it's the same way, but yet we've turned it around, so it's a rotation. And that's it. That's it for this lesson. So there's one more left. Hang in there. We're almost there. We're almost through chapter 9. If you have any questions, comments, concerns, please let me know. Otherwise, until next time, we'll talk to you later.